Hello, my name is Gregory Scott, and I'm here to talk to you today about Service Robotics and Technologies and our software platform for facility health monitoring in defense buildings and infrastructure. But first, let me give you a quick intro of myself. I got my dream job out of college, launching the space shuttle from NASA's Mission Control Center in Houston, Texas. After the Columbia accident in 2003, I moved overseas to do my PhD in space robotics at a university outside of London. And from there, I was headhunted by the U.S. Naval Research Lab in Washington, D.C., to build up a research portfolio around robotics and sensor systems in extreme environments, including space, deep sea, and even battlefield systems. Although managing multi-million-dollar research projects for the new U.S. Navy was exciting, after 6.5 years, I created SRT Labs and started designing the Mission Control Center for smart buildings, which is what I'll tell you a little bit more about in the coming slides. SRT has built the M1 portal, the Mission Control Center for Smart Buildings. We create a common ecosystem of building data for monitoring, analyzing, and automating systems across buildings. This includes integrations with our technology partners across building automation systems, Internet of Things devices, and even robotic platforms. Once together, this data ecosystem allows for us to create building intelligence from disparate systems, allowing for optimizations and automations across buildings and campuses, creating a more efficient process and saving resources along the way. Our platform has been built on government and private funding, with development starting through the National Science Foundation SBIR Phase 1 award in 2017, after which we submitted our first patent, which was recently awarded to protect our developments in map-based data management for the integration of robots and smart devices. Development was extended through Navy SBIR awards in 2020 and 2021, allowing us to dive deeper into infrastructure and facility health monitoring, as well as other contracts in HVAC schedule optimization, warehouse automation, and more. We have a diverse and inclusive team of nearly 20 employees today. Many of our team, our members have experience in government contracts and academic research projects, allowing us to understand what the government wants to see and where our platform best fits across military bases and infrastructure management. We have applied our software platform to the Navy SBIR 2020.1 topic N201-X02, Focus Area 7, which is Facility Health Monitoring and Prioritization, where facility managers are seeking integrated facility health monitoring systems to track real-time health status of buildings. We're applying our platform across 2 Department of Defense bases, the Marine Corps base at Albany's Maintenance Depot for the Marine Corps, the MDMC, as well as at Puget Sound Naval Station, in a dry dock and a machine shop. We see acquisition programs across the U.S. Marine Corps Logistics Command and naval shipyards, as well as applications across Naval Facilities Command and the U.S. Army Corps of Engineers. Now, let me dive into some specific details to the problems we're addressing at the MDMC in Puget Sound. Both of these groups, as well as many others across the Department of Defense, are looking to reduce downtime of critical, often legacy facility infrastructure. To demonstrate this capability, we are primarily focused on this project in demonstrating how our platform and the vehicle maintenance depot infrastructure, such as paint booths and blast booths, as well as shipyard dry docks, as well as machine shops through monitoring machine operations. In each of these cases, we're able to utilize our software with aftermarket sensors to provide modernized monitoring to antiquated systems and providing predictive notifications for anticipated machinery usage and downtime. And we've done this through our M1 portal, the Mission Control Center for Monitoring Facility Operations. We pulled data from deployed sensors across the facility or shop, creating a common ecosystem out of devices from different manufacturers. This hardware-agnostic software platform provides insights to facility operations without having to overhaul expensive and often one-of-a-kind equipment. One view of our software is shown here, a map-based overview of a facility showing the locations and the status of every individual sensor deployed across the facility. Additionally, we provide customized dashboards showing the key takeaways from this data. For the MDMC, we're focusing on monitoring facility usage, predicting downtime, providing preventative maintenance updates for filter changes, for fan motor servicing, and even machine runtime. For Puget Sound, we're providing a more easily accessible information from several different sources in a single location, reducing their need to walk to the depths of the dry dock to see the status of their facility. Our platform is fully operational and commercialized for specific operations. So we are at a technology readiness level 9 for the core operations of our M1 portal. We're in the process of working with our NAVC sponsor to find an optimal program of record for transitioning the specific facility health monitoring developments that we've been working on with the MDMC and Puget Sound. When looking at new applications of our platform, we're more of a technology readiness level 7+, with active commercial deployments and deployed prototypes with several different government applications. And this allows us to do customizations of our core platform for individual fleet or facility applications. Now, this rings true for warehouse automation. We currently have an OTA and other transaction authority contract with the Marine Corps Logistics Command, as well as commercial applications and campus-wide heating, ventilation, and air conditioning optimization under contract at several different universities. Now, here's what I'm most excited about and what we've built with the M1 portal. We're able to use our platform to tap into existing building infrastructure systems, as well as complement this system with various aftermarket sensors from our technology partners in order to build a single ecosystem of data from a variety of all these different platforms. This allows us to do cross-platform analytics, developing algorithms to capture off-nominal building and machinery operations, as well as optimize building operations. Now, we can leverage our machine learning capabilities to find indicators of larger problems or recurring issues that persist over time. Overall, this allows for our low-cost software to provide significant return on investment in monitoring high-value assets across facilities that exceed what manual processes can provide. As we work through our transition plan beyond our ongoing SBIR Phase 2 Option 1 program, we've identified several options for deploying our platform into the Department of Defense, as well as extending the research component for additional DoD applications. Our primary focus is on identifying the appropriate program of record for enterprise-level facility health monitoring software. We're also starting to review existing prime contract awards in this field to work directly with these primes on opportunities within their existing contract mechanisms. Our strongest advocates in NAVC and the Marine Corps Logistics Command are also supportive of extending our prototype deployments at the MDMC and Puget Sound, though budget availability for these groups without alignment on a program of record is a difficult road to follow. When we look at the market opportunities that align for our platform, we could argue that every building on the planet would benefit from our software. However, in reality, we are focused on specific applications of our software, at least in the near term. In the government space, we're looking primarily at machine and facility health monitoring in a way that provides real-time information about the health of facility systems. This supports runtime monitoring and downtime prediction, as well as schedule optimization for needed maintenance. We also have a warehouse management and automation application for our software currently supporting an OTA with the Marine Corps Logistics Command and should be ready for greater expansion across the Department of Defense and commercially in the next year. Now, specific on the commercial side, we're focusing on campus-based facilities, such as universities or commercial campuses, as well as the building service contractor industry that manages numerous different locations. This creates an enterprise-level platform that provides significant process and schedule optimization for the machinery and systems and processes across these campuses. As an enterprise-level software platform, we require a few steps to fully deploy within a facility or across a campus. We start by providing a needs assessment or scoping documentation on how we would address a specific customer need with our software. Then we develop a detailed pre-deployment document specifying the hardware and integration requirements, as well as the dashboard mock-ups for the customer. Finally, we work on software upgrades and customizations for the customer as we deploy supporting hardware and integrate them within our existing systems. Certainly, NAVFAC is an ideal transition partner for us in this respect, as we can provide facility health monitoring across buildings, bases, and continents using a single data management ecosystem. When looking at transition partners whose contracts we can support as a subcontractor, we see that there are several primes that have contracts in the facility infrastructure support and management areas. Similar to our approach on the active OTA that we have, we would propose to these primes to support their existing or future contract acquisition processes. This would certainly apply within NAVFAC as well as NAVC and some shipyard subsystems and maintenance programs. Now, as I close out this presentation, I would love to connect with you and your teams to discuss how our facility health monitoring platform can improve your facility operations and optimize processes to save time and budget. We can be reached in person in the Washington, D.C. and Salt Lake City areas and are happy to set up a virtual or on-site demo of our platform and how it would specifically apply to your situation, your building, or your base. I look forward to meeting up with you and your teams real soon.